Hi, I'm Nick, and I'm back with another installment of Layman's Terms with Nick. Now, in this series, if you're new to this, I'm sure that you are. This is only the second episode. I'm going to go through this book. It's called How Things Work. This is the third edition. I'm going to read different technical information on parts and engineering terms and try to see if I can figure out a way to boil it down so that really anybody can follow along. And with that, we're going to jump right in. This is the second part of four of the series for ball and roller bearings. I've added the graphic on here so that you can actually follow along. It'll be a little bit easier too. With that, you can read the text and see the figures that we're talking about. Ball and roller bearings continued. Radial bearings. Single row grooved ball bearings, seen in Figure 1, are most widely employed. They can take some thrust as well as considerable radial loading, even at fairly high speeds. Double row bearings of this type are also used. Angular contact bearings, illustrated in Figure 2, can resist larger amounts of thrust than grooved ball bearings. The term magneto bearing is applied to a single thrust ball bearing with separately detachable outer and inner races, making for greater convenience of assembly. The self-aligning ball bearing, seen in Figure 3, has a spherical track in the outer race which enables it to compensate for misalignment. Such bearings have only a fairly limited load carrying capacity. Cylindrical bearings, seen in Figure 4, have a much higher radial load carrying capacity than ball bearings of equivalent size, but are generally not able to resist any considerable amount of thrust. In the bearing illustrated, the locating lips, or shoulders, are formed in the outer race. Needle roller bearings, in Figure 5, have relatively long rollers of small diameter. Their one advantage over normal cylindrical roller bearings is the radial saving space. In other respects, they are much less efficient. Needle roller bearings are used in low-speed, heavily loaded positions. A double-row self-aligning roller bearing is illustrated in Figure 6. This type of bearing can compensate for shaft misalignment and can resist thrust in both directions as well as considerable radial load. The taper roller bearing, seen in Figure 7, is suitable for any combination of thrust and radial load. The single row type, as illustrated, can take thrust in one direction only, and as with angular contact ball bearings, it is necessary to fit two bearings on each shaft if there's any possibility of two-way thrust. Barrel-shaped rollers are suitable for bearings subjected to heavy impact type loading. Such bearings are moreover self-aligning, but the thrust capacity is very low. Thrust bearings. Ball thrust bearings, seen in Figure 8, can take thrust loads only and are used chiefly where a shaft revolving at not too high speed requires rigid axial support. Angular contact thrust bearings are suitable for higher speeds. Self-aligning roller thrust bearings, seen in Figure 9, differ in performance from any other types of thrust bearings in being able to resist radial loads as well as thrust, besides allowing angular movement between shaft and housings. Other forms of thrust bearing are the cylindrical roller thrust bearing, the needle roller thrust bearing, and the taper roller thrust bearing. These types of bearings are suitable only for fairly low speeds. Now we've seen what the book has to say about radial and thrust bearings. Let's see what layman's terms Nick has to say about them. There are many types of radial bearings. The most commonly used are single-row grooved ball bearings due to their ability to move at high speeds, even when some thrust and high radial loads are applied. Now for heavier loads, double-row grooved ball bearings are used. For higher thrust resistance, angular contact bearings are used, and just like grooved ball bearings, a second row may be necessary for heavier loads. Now, when you have lighter loads and you want to combat shaft misalignment, self-aligning ball bearings are used. When thrust is not an issue, but limited space and high loads pose a threat, cylindrical roller bearings may be necessary. If radial space is an issue, but thrust, high speed and heavy load requirements or not, then a needle roller bearing is your best option. Self-aligning roller bearings can take on thrust from either direction, fix misalignments, and carry heavy radial loads. But when there are size constraints and thrust from both sides and heavy load are a threat, tapered roller bearings are the best option. Now we go on to thrust bearings. For shafts revolving at low speeds requiring rigid axial support, ball thrust bearings may be your best bet. Now that's only provided the only load is thrust. When radial loads pose a threat in the same type of scenario, then self-aligning roller thrust bearings are needed. All right, so you've heard from the book, you've heard from Layman's Terms Nick. Comment below, let me know what you think, and we're looking forward to seeing you next week for part 3 of Ball and Roller Bearings by Layman's Terms Nick. Thanks.